Have you ever wondered where you might end up if you were to enter a black hole? Would it lead to another universe, another point in space, or simply to your doom? The enigma of black holes has captivated the minds of the scientists and laymen alike for decades. These celestial entities, shrouded in mystery and cloaked in darkness, are the stuff of both scientific research and science fiction. The fascination with black holes isn't surprising. They are, after all, the ultimate cosmic monsters, the epitome of enigmas, the final frontier of the known and the unknown. They are regions of space where gravity is so strong that absolutely nothing, not even light, can escape their grasp. This makes them invisible to the naked eye, and yet their influence is so profound that they shape the very fabric of the universe itself. Often, black holes are imagined as portals leading to other universes or shortcuts to distant parts of our own universe, like a cosmic rabbit hole. We fantasize about where a plunge into a black hole might take us. Would we be transported to a different time or place? Or would we find ourselves in a completely different universe, a parallel reality perhaps? But amidst our wild speculations and fantasies, we must not forget the harsh reality. Venturing into a black hole isn't akin to a magical journey. It's more like a one-way ticket to oblivion. The immense gravitational pull of a black hole is thought to be capable of ripping apart anything that dares to come close, stretching it into a thin stream of atoms in a process rather gruesomely known as spaghettification. So, before we get carried away with our imaginations and leap into the unknown, let's first understand what these cosmic monsters actually are. After all, it's always wise to know your monsters before you decide to dance with them. You wouldn't want to find yourself at the event horizon of a black hole, only to realize too late that escape is impossible. Stick around as we unravel the mystery of black holes. Black holes are not just random spots in the universe. They are the remnants of massive stars that have died spectacularly. These celestial bodies are the final resting place of stars much greater than our Sun. When such a star has burnt out all its fuel, it can no longer sustain the nuclear reactions that keep it shining. As a result, it collapses under its own weight, creating a massive explosion known as a supernova. But what happens after the fireworks? The core of the star, now exposed, is left behind. This core is quite small but unbelievably dense. In fact, if the core is more than roughly 3 times the mass of our Sun, something extraordinary happens. The force of gravity becomes so overpowering that it pulls everything, including light, towards it. This is where our journey to the formation of a black hole begins. Gravity, the cosmic artist, then takes over. It's as if gravity is sculpting the universe, pulling and pushing matter into its desired form. In this case, it's creating something so dense and so heavy that it bends space and time around it. This is called a singularity, an entity with infinite density. This process is so intense and the gravity becomes so strong that nothing can escape its pull. Around this singularity, an invisible boundary forms. This boundary, or event horizon, is the point of no return. Anything that crosses this boundary, whether it's a planet, a star, or a beam of light, is destined to fall into the singularity. It's like a cosmic waterfall. Everything that goes over the edge will inevitably fall towards the singularity. So, what we get in the end is a black hole, a point in space where a star once lived, now turned into a cosmic trap from which nothing can escape. It's a place where the normal laws of physics cease to apply, where space and time become a tangled mess. And there you have it, a black hole, a point in space with an infinite density and immense gravitational pull. Imagine standing at the edge of a black hole, the so-called event horizon. What would happen to you? The event horizon is a point of no return around a black hole. It's that boundary where escape becomes impossible, even for light. Once anything crosses this threshold, it's drawn inexorably towards the black hole's core, the singularity. German astronomer Karl Schwarzschild first proposed this idea, and it's been chilling spines ever since. But what would this journey look like? Here's where things get even more hair-raising. You would experience something known as spaghettification. Yes, it sounds like something out of an Italian cookbook, but it's far less appetizing. Spaghettification is a process that occurs due to the extreme tidal forces within a black hole. Tidal forces are differences in gravitational pull. On Earth, they cause our ocean tides, but near a black hole, these forces are so powerful they can stretch and compress objects into long, thin shapes, like strands of spaghetti. So, as you fall towards the singularity, your body would be pulled into a string of atoms. Your feet, being closer to the black hole, would feel a stronger gravitational pull than your head. This would create a stretch, a tension, eventually pulling you into a thin string of atomic spaghetti. Not exactly a space vacation you'd want to experience. And what happens to this spaghetti? It's believed to end up crushed into the singularity, the black hole's infinitely dense core. This is where our understanding reaches its limits. The laws of physics as we know them seem to break down at a singularity, leaving us with more questions than answers. So falling into a black hole might not be the best idea if you value your current shape and size. But don't worry, black holes aren't exactly lurking around every cosmic corner. Still, their mysteries continue to captivate us, a testament to the fascinating, sometimes terrifying wonders of our universe. But what if black holes are not just cosmic vacuums? What if they are gateways to other parts of the universe, or even to other universes? This intriguing proposition has captivated scientists for decades. It stems from the concept of wormholes, hypothetical bridges piercing the fabric of space-time, connecting distant points in the cosmos. The idea of wormholes was put forth in the mid-30s by Albert Einstein and his colleague Nathan Rosen, giving birth to the term Einstein-Rosen bridges. However, the concept didn't gain substantial traction until the 1980s, when physicist Kip Thorne rejuvenated the discussion. Thorne, a leading expert on the implications of Einstein's general theory of relativity, questioned whether objects could physically traverse these space-time shortcuts. His work sparked the imaginations of many, including our very own Professor Richard Massey. Reading Kip Thorne's popular book about wormholes is what first got me excited about physics as a child, Massey recalls. However, Thorne himself expressed skepticism about the practical existence of wormholes. In his book, The Science of Interstellar, he wrote, "We see no objects in our universe that could become wormholes as they age." Thorne's skepticism is echoed by many in the scientific community. The notion of using black holes as wormholes remains largely theoretical, with no substantial evidence supporting it. The key obstacle is our inability to observe or measure what occurs within a black hole. Their overwhelming gravitational pull prevents even light from escaping, making direct observation impossible. Yet the theory persists, fueled by our insatiable curiosity and the tantalizing possibility of cosmic shortcuts. Could black holes be our ticket to distant galaxies or even other universes? Could they be the key to unlocking the secrets of space travel? Or are they simply cosmic phenomena that defy our understanding? We may not have the answers just yet, but the quest for knowledge pushes us to explore these fascinating possibilities. As we continue to delve into the mysteries of the cosmos, who knows what astounding discoveries await us? However, as tantalizing as the idea of using black holes as cosmic shortcuts is, it remains firmly in the realm of theory. As of now, black holes remain enigmatic and elusive. We can't see them, we can't photograph them, and we certainly can't explore them. They are the unseen and the unknown, the celestial spectres that lurk in the farthest corners of the universe, defying our understanding and challenging our curiosity. Their very nature, the immense gravitational pull that swallows even light, makes them invisible to our eyes and our instruments. They are like phantoms in the dark, only revealing themselves through their effects on the surrounding space. It's akin to knowing the wind is there, not because we see it, but because we see the rustling leaves on the trees, the ripple on the water's surface. And yet, despite their elusive nature, black holes are not entirely beyond our grasp. Scientists have found ingenious ways to study these mysterious entities. They observe the behavior of stars and gases around the suspected black holes, looking for telltale signs of their presence. They study the X-rays and radio waves emitted from the vicinity of these cosmic beasts, using them as indirect clues to piece together the puzzle that is a black hole. Then there's the groundbreaking Event Horizon Telescope project, a global network of telescopes that captured the first ever image of a black hole's event horizon in 2019. It was a monumental achievement, a testament to human ingenuity and persistence, offering us a tantalizing glimpse into the realm of the unseen. And yet, for all our progress, we still have more questions than answers. Where do black holes lead? What lies beyond their event horizon? Could they really be gateways to other universes, as some theories suggest? Or are they cosmic dead ends, places where matter and energy go to disappear forever? So where do black holes lead? The answer for now remains as elusive as the black holes themselves. But who knows what future research might reveal? In the grand cosmic theatre, black holes may yet have secrets to share, stories to tell, and we, ever curious, will continue to seek, to explore, to understand.